Okay, so what we're doing for 825 is completing the square. So I'm just going to read to you what I have over here. So if a quadratic is in the form, in standard form, y equals ax squared plus bx plus c, but is not factorable, we can complete the square to put it into graphing or vertex form to solve for x. And we can solve for x-intercepts, y-intercepts, your vertex, especially if it's in vertex form, all that good stuff. So over here, when we go and try to complete this square over here, I think I left my other colors in the back. Hold on 1 second. Okay. All right, if we go and try to factor this thing the way that it is, it's not going to be factorable. So if we take this guy and we just go straight into our diamond problem, what we'd have on top over here is 10x squared, and then on the bottom we'd have 8x. And that's not factorable. I can't say, like, I only have 10 and 1, that doesn't add to be 8, and I have 2 and 5, that doesn't add to be 8 either. So that means that this guy is not factorable. So completing the squares, we're literally going to use algebra tiles over here. So if you have different colors, you can use, I have like this guy for my x squared. I'm going to have a 4x4 box. My x is just going to be 4 long by 1. And then my 1s are just going to be 1 box, and my y is going to be like that longer one. So I'm going to do it with the actual algebra tiles first. And then we're going to write it down so all of you guys can write it down too. So I'm just going to do what I have over here. So this is my y over here. I have 1x squared. I have 8 x's over here. And then I have 10 ones. I have a lot more than 10 ones. 2, 4, 6, 8, 10. Okay? So I have all of these over here. It looks like a gigantic mess. But just like the name implies, by completing the square, I actually want to turn these algebra tiles into a square. So obviously this is going to be my corner one. I'm going to have this guy as a square. But hopefully what you guys start seeing is if I'm going to make a square, that means I'm going to have to take these ones, and for every one I put on the side, I'm going to have to put 1 on the bottom. Okay? Because if I put like all 3 of these over here, now I have a rectangle. It's no longer a square anymore. So I have to make sure that I'm trying to keep these guys as even as possible. So if I have 8 x's, which is these long pieces, if I have 8 x's, that means I should be splitting them up into 4 and 4 over here. Then, if I'm going to complete the square, obviously I'm missing a whole bunch of pieces over here. Now for this particular problem, I only have 10 ones. So I have 1, 2, 3, 4, and then I have another 4. Whoops, they stick to my fingers. And then I just have 2. So if I want to complete this square, how many more 1s am I going to need? How many more 1s am I missing? Well, I need 1, 2, 3, 4, 5, 6. And once I add those 6 ones over here, now you guys should see I have a perfect square. However, for this, it's not mathematically correct if I add 6 ones to this side, but I don't add 6 ones to this side. So I'm going to have 1, 2, 3, 4, 5, 6 ones that I'm just going to add to the y over here because this is like the 2 sides of my equation. All right? So now what I'm going to have you guys do is we're just going to write this down using your pens instead of these algebra tiles so you can have them all on your notes. So remember, this is my y. So I'm just doing like a 6 by 1 rectangle for my y. And then on this side, I have my x squared. So I'm making a 4 by 4 x squared. And then these guys, I'm splitting my x's into 4 and 4. So each one of these are x's. And then, since I have 8 x's, I also need 4 more x's down here. And then we were given 8 ones. So we were given 10 ones. So we were given all of these guys over here and 2 extras. And what we said was we needed 6 extra ones to complete the square. So I'm going to add ones. These are just like our plus ones over here. And I need 6 of these in order to complete the square. But that also means that I need 6 ones over here. So I need to be adding 6 ones to both sides. Okay. So now what I have over here, now we're just going to translate this. So what I really did over here, this side, and remember this guy was a y, even though I didn't label it. Now on this side, I have y plus 6 ones. And since we are trying to turn this into vertex form, remember how vertex form looks like this? We had y equals a times x minus h squared plus k. We want to turn it into where we have something squared. Look at this square that we just made. And this is where knowing how these algebra tiles work really comes in handy. So remember over here that this whole side over here was an x. This whole side up here was an x, which is why we have x squared. All of these sides down here are just ones. All of these guys over here are just ones because they have those short sides. So really, each one of these sides is now x plus 4. So we have x plus 4 times another x plus 4, but again, I want this in vertex form, so instead of that, I'm just going to write x plus 4 squared. Okay, however, what I have over here is not quite in vertex form yet. What do you think I have to do to this guy in order to get it to be into vertex form? Because I want y equals whatever. What do you think has to move? Go ahead. The 6. So I'm going to subtract the 6 on both sides. So now I'm going to have y equals x plus 4 squared minus 6. So now I turn standard form into vertex form. Okay. So now let's answer a couple of questions. If this is my vertex form, what is going to be my vertex? Who remembers that from over a week ago? So your vertex is always what in vertex form? What are you actually pulling out of these guys? Say it again? Well, not necessarily that. I want H and K. And remember, I always want the opposite of whatever H is. I like writing it negative H. And then I have K as well. So for this particular problem, what's going to be my vertex? Negative 4 and what? What? Negative 6. Okay. So that H is always going to change because I technically have like x minus negative 4. It's always the opposite of what it seems. The K, whatever that is, that just comes down. As far as my y-intercept goes, I can just plug in 0 for x. 0 plus 4 is 4. 4 squared is 16. 16 minus 6 is just 10. But again, I should be able to look up here and be like, oh yeah, my C was actually 10. So this one, there's a couple of different ways that you can get your y-intercept. Your x-intercepts on here are the ones that are going to be the trickiest. So remember, your x-intercepts is where you are plugging in 0 for y now, and you're solving for x. So we're going to have to do a little bit of work down here. And these, again, we're going to have 2 different solutions. So let's do our work. Plug in 0 for y. We have x plus 4 squared minus 6. Now, starting from vertex form, we have to go backwards a little bit, where, again, I'm going to have to add the 6 on both sides. So we're going to have 6 over here equals x plus 4 squared. And then we need to undo the square. What undoes a square? It's a square root. So your square root and your square cancel out. But I need 2 different solutions. So whenever I take the square root of both sides, the side without the x is always going to be a positive and negative version. Since 6 is not a perfect square, I'm just going to leave it the square root of 6. And then since this square and the square root cancel out, now that's all that's left on this side is an x plus 4. And then I still have to solve for x, so that means I have to subtract 4 on both sides. So for these ones, since it was not factorable, remember when we put these into decimals and they're like, oh, our estimated solutions were like 1.27 whatever, this is going to be one of those estimated solutions. So this is how you're going to write your two different answers. So I'm going to put this -4 first because I have a plus and minus root 6. So for this one, x is going to equal -4, and we're going to add the root 6 first. And then down here, x is going to equal the -4, and then we're going to subtract the root 6 for the second one. So I like those plus and minus ones in the middle over there. And then these are your exact answers. If you put them into your calculator, you will get those estimated answers, all of that good stuff. But this is just one way how to solve algebraically through completing the square. Okay, and we're going to practice more of this tomorrow as well.